Okay, to solve question 21 on probability, the question states, a coin is tossed 10 times, and as you would expect, the probability of heads on each toss is 50%, and it wants us to evaluate each probability. And probability A is a probability of exactly 5 heads. What we're going to use for this is we're going to use the binomial theorem. The binomial theorem is another theorem used to expand binomials. We focused on Pascal's triangle, but there are other methods. This method also provides us with a basic formula for solving probability questions such as this. It does use combinations with n and r. N is the total number of trials. R is, I guess, the undesired results, or what we might call a failure. So in this case, if we want 5 heads, then we would also be getting 5 tails, which we would consider the undesired result. So this would be set up as 10 combination 5, and then P to the, we'll call it S, times Q to the R. Now, P is the percentage of success. And on each toss, the percentage for success is 50%. So that would be 0.5. Raised to the S, I guess we could say that the S stands for the number of successes, which in this case would be 5 heads. So we have 5. The Q stands for the percentage or percent chance of failure. So for each toss, it's also 50%. And R is the same R we used here, so it's 5. These percentages should add up to be 1. This S and R should add up to be N. And if we were to evaluate using our calculator, which we would need to do, we should get, I believe, approximately 25%. And we'll work that out very quickly. While this is loading up, we can go ahead and start to set up question part B. And in part B, it says, what's the probability of exactly 6 heads? We're going to use the same formula. This time, however, it's going to be 10C4, because remember, if we're looking for 6 heads out of 10, the remainder, then the undesired result would be 4 tails. Then the percent of success, again, is going to be 0.5, but this time it's going to be raised to the 6th power times 0.5 raised to the 4th. And then for part C, exactly 7 heads. It's going to be 10C7 point, not 7, 3.5 raised to the 7th times 0.5 raised to the 3rd. So as we evaluate these, we have 10 math probability combination. First one was 5 times 0.5 raised to the 5th times 0.5 raised to the 5th gives us 0.246, or approximately 25%. For part B, we would do the same thing. Except this would be 0.5. This would be raised to the 4th. This would be raised to the 6th. And this would be 4. And that would give us approximately 21%. And then for the last one, this is a large screen. This would be 3. This would be raised to the 7th. And this would be, still be 10. sorry, arrow too many times, this would be 3. And then we get approximately 12%. And that is how you solve question, 12%. And that's how you solve question 21.